for our next keynote, we're looking at enabling the metaverse and 5G and 6G with AI. Our speaker is Steve Bowker, Head of AI Platform and Architecture at Ericsson.
Steve has over 25 years of deep technical domain experience. His market understanding and architectural and system engineering skills have given birth to numerous innovative software and solutions. Steve, the floor is yours.
It's a pleasure to be invited to speak at the AI Summit for ADL. Recently, actually, I participated in a Catalyst project with the TM Forum on measuring trust in AI as well, which is very relevant to this. We saw a presentation earlier on about the trust needed for Metaverse, which obviously is another dimension more complicated. So it'll be interesting to do another phase of that in future. So as I just mentioned, I've actually just joined Ericsson. I'm in their solution area cognitive network solutions. So that's the part of the company that basically uses AI to generate new solutions to do things like optimize the network, to run new services, to do all kinds of clever things with new services. Maybe things like managing new slices in a 5G network, and in future lots of interesting things in 6G. So without further ado, I'll move forward into the presentation. So Ericsson has a vision to imagine a world where limitless connectivity means limitless possibility. So we're trying to shape the world so that you can have services that deliver what you want when you want. And a typical challenge for that is, of course, the metaverse itself. That's been touted probably since the late 90s. You've heard the story about the book that inspired it all, but there's also been different variants of it from different gaming consoles. Ready Player One, the movie. There's lots of things out there today. And one of the reasons I said enabling the metaverse on 5G is it is actually possible to provide metaverse type capabilities today, but also obviously as the technology evolves onto 6G, it's going to get even more interesting. Just to give you a little bit of background on Ericsson itself, obviously probably everyone's heard of Ericsson. We serve customers in more than 180 countries around the world. We've been in countries like China, Brazil, and India for more than 100 years. We've got various R&D facilities, manufacturing, service delivery centers around the world. And as you can see, the Southeast Asia and Oceania region, which is basically the area that the Exiata group operates in, has 26,000 employees. So we're very well represented in the area. Excuse me. Talking specifically about 5G, I'm sorry, my mouse is on the screen there. Talking specifically about 5G, we've got 134 live networks at the moment in 59 countries. That's serving over 1.2 billion subscribers. So Ericsson were rated recently in the Magic Quadrant by Gartner as a high provider in the 5G network infrastructure. So they're a leader in the segment. So just to give a little bit more background. So obviously Ericsson is probably well known for the 5G digital infrastructure. When it comes to technology leadership, the radio access network, core network, communication services, and all the support functions like OSS and BSS are there. Ericsson like to work in a sustainable way. We like to provide a reliable and resilient network infrastructure, and obviously in a secure environment. As we're building out the 5G infrastructure, a data-driven approach is a lot more important, and there's a lot more AI involved in the fabric. Moving up, oops, sorry, wrong way. Moving up in this section in the middle, you can see there's a wide range of network capabilities to provide different values. So whether it comes from coverage to provide voice, broadband, or applications. With things like Metaverse, the latency of the performance is probably more important than the bandwidth, but you can have high speed and low latency networks. It's important to be able to orchestrate it. So moving into a customer experience environment, being able to orchestrate things at a slice layer. So maybe several hundred or maybe several thousand slices will be required to implement the Metaverse. The processing, and we'll get into this in a bit more detail later, whether the processing is on device, on an adjunct device, on the edge of the network, or in the core of the network. That becomes quite interesting. You need to be able to support different services. And I think there was a great example earlier from Huawei where they showed the container port and the operation. Being able to support private networks is a key thing there. And all the time to have a trusted execution environment, and again, in the container port, IoT solutions, and the ability to make sure the quality of experience is good enough. Oops, keep going the wrong way. So of course, there's lots of different use cases to support 5G, whether it's straightforward enhanced mobile broadband, smart cities, all the smart cameras around, there's lots of different smart devices, automotive, transportation. We're not going to read them all out, but there's lots of different smart manufacturing. Ericsson have a smart manufacturing setup in North America. There's a featured blog and a nice video on that if you're interested in looking at that. And there's all kinds of other logistical things. And again, because we covered it quite well earlier, I don't need to emphasize that. So our purpose is to create connections and make the unimaginable possible. So the idea is to combine creativity, expertise, and technology. So what we have here is a little video of the future, but it's not that far into the future. So I'm just going to start that playing.
Oh, this technology. As soon as you think you've seen it all, here comes something new. Access our sensor. It's quite amazing, all the things we can do now, even if I do get a little tired of it sometimes. Everything is constantly evolving,
Hi, Laura.
advancing.
Except the jacket's warm, so it's going to be cold today.
We're surrounded by change, always connected without even noticing it most of the time. Just when I've gotten the hang of one thing, another shows up.
Hi, sis. Just wanted to see how everything's going. Is there any news?
I guess that's what happens when you get to be my age.
Nate.
Some worries still remain, of course. I think worrying is part of human nature.
Yeah, we're all good here. We're just waiting for the medic, so we'll
We
be back in
need
touch
it
soon, okay?
to keep moving forward, keep advancing.
We'll be back in touch soon, okay?
It does amaze me just how far we've come, how accessible everything is today. There's so much less worrying, less stressing, and with that comes more freedom. There's something magical about us all being connected to one another. It's like we're never alone anymore,
Except.
for better or for worse.
Hi Chris, sorry for the interruption. Robot 43 is down. Could you locate when and where the problem occurred?
Yeah, sure.
We need to implement
It
fixes.
brings us closer together, no matter where in the world we happen to be.
Okay.
And it makes us all equals. I do love that. Age, background, disabilities, it just doesn't matter as much anymore. There'll always be new problems to solve, new issues at hand. We're only human after all.
Call Dr. Waffle.
We've always known that technology would help us connect to one another more, help bridge the distances between us, but we could never have known to what extent. There's so much potential out there. As long as we continue to create with good intent, we can keep making the world a better place and keep bringing people even closer together, no matter where in the world they happen to be. You see, things don't just happen by accident. A thought, a dream, a plan has to align with technology, like stars aligning in the sky. It's of course impossible to foresee the future, but we can hope, dream, and plan best of our abilities. That's how we, you, me, your little baby cousin, all of us can advance.
So that's quite interesting. There are many aspects of the metaverse were represented in that video, but I thought I'd do a couple of interesting screenshots here. So looking at the top left-hand side, you can see a street view. You know, if you're wearing some appropriate glasses or AR headset, you can get augmented information. Maybe as you walk down the street, so as simple as mentioning the name of the shop, the latest rating, and that type of thing. If you look a little bit to the right, you can see there's a slightly more complicated view of a street view. It's giving you a bit of navigation. It's showing you where your colleagues are. It might be showing the meeting you're heading to. And more importantly, if you need the loo, it's giving you a continuous update of the closest restroom. You could take that a step further and say the closest available restroom, because if the restrooms are smart as well, they'll know when they're occupied or not occupied. So it gets quite interesting. The bottom left-hand corner, this is a firefighting scene. So if a firefighter's in a building, they can take a look, or in the case the picture is showing a guy in the building trying to get out, he can find the closest fire escape to run out. But in the situation of the firefighter themselves, they can get the floor plan of a building. They may not be familiar with it. It can show where the fire is worse, where the people need rescuing, and all kinds of interesting information like that. Obviously, in the bottom right-hand corner, this is where there's been a lot of trials like this in the US using mobile devices, where you get the current stats of a game presented on the device, but also if you're wearing glasses or augmented reality environment, you can get the stats on the current game, you can get the stats on the players. Maybe your eyes focus on a particular player, it brings up their profile, and it starts to get very interesting there as well. And of course, with the World Cup coming up, you get to the quarterfinals. Not only do you want to know the stats of the game that you're watching, you want to know how the other team in the same group's doing, because sometimes it comes to the goal difference in the games to get through. So I've already mentioned a few terms, things like virtual reality, augmented reality, and mixed reality. They all fall under an umbrella known as extended reality, and the abbreviation is XR. But if I briefly just go into the different types. So virtual reality, this is your Oculus Rift headset. It's your Sony PlayStation VR glasses, where you're completely immersed in the glasses. You only see the reality created, and that's showing you the basically virtual environment. And it's great. You can go on trips, go traveling around the world from your own lounge, and do lots of exciting things like that. Mixed reality is where it starts getting very interesting, where you can sort of interact with elements in real world objects. And then augmented reality, the examples I was showing on the previous page is augmenting a real picture, or augmenting reality. So that's kind of how it all fits together. If we put it all together, the metaverse is going to be a mix of VR and AR and MR experiences, and they can be shared and persist as well. So it's going to be a really interesting environment. I think when Mark Zuckerberg rebranded Facebook, or the parent company, to become Meta, and they announced their vision for the metaverse, it was very much a virtual reality environment. I think the real environment out there is going to be augmented reality, of course, with a virtual reality places to go into different interactions. I thought I'd look at some of the devices. You see lots of different types of devices, whether it's 2D access, so that could be a TV set, could be your smartphone, or a computer, for example. And a great example of that is when you're playing an adventure game and you're going through and you're looking at that. That's effectively a metaverse that you're entering in that respect. It starts getting more interesting when you bring 3D into it, whether it's on the VR glasses that we just talked about, or a 3D TV set, or a combination of that. Holographic projectors do exist. It's very difficult to get it in good lighting conditions and pseudo-real, but they exist, and they will get much better over time. Of course, the really interesting stuff is when you go for more than 3 dimensions, you start introducing things like touch with haptics. So both being able to control things by using haptic gloves to show, like classic remote surgeon case, or getting feedback. So Ready Player One, the suit gave you an electric shock to get you paid, and there's things like smell-o-vision. Sensors like smell could be introduced as well. And the really cool thing is, if you look in the bottom right-hand corner, the next slide actually covers that in a bit more detail. In the longer term, sort of the late 20s, the 2030 plus timeframe, there's going to be things like lenses that can be put on you, just worn. So there's two different out there. Mojo have developed a lens which has got a neck worn computer. So you wear a computer around your neck, so the processing power is sitting there, and it's projecting onto your glasses. InWithCore is developing soft electronic contact lenses and claims the most advanced platform for experiencing the metaverse. So basically very similar to soft contact lenses today. So imagine that, getting a view like the left-hand side without even wearing glasses. So that's the exciting stuff to come. So this Dribble website is, there's a link there, and you can see the video, but it's got a lot of interesting concepts around the metaverse as well. So it's quite an exciting page to have a look at. If everyone's a Harry Potter fan, there was a proof of concept done with AT&T. It was a combination of AT&T, Ericsson, NVIDIA, Qualcomm, and Dreamscape. Basically, you're able to walk around a Harry Potter environment and experience Harry Potter. So that's a bit of fun there. There's a link in the presentation material as well. Again, here's some more graphics. The bottom left-hand side is from Westworld. He's trying to just try on a suit, but instead of having to physically try them on, you just choose them on a virtual display. The right-hand side is interesting as well. If you're wearing an AR headset or AR glasses or even the AR contact lenses, looking in your engine hood, you can check it just simply by looking at it. And you don't even need to open the hood really, but it's just a great concept of looking at that. And if you take it a step further, the engineer can have more advanced diagnostics running as well. So it's all very, very powerful when you look at what's possible and you open your imagination. So some examples of extended reality in the industry. The one on the left is quite interesting. NASA and Lockheed Martin, they were using Microsoft HoloLens, and they used to take 8 hours to do the maintenance on satellites. So basically they had to double check things, read it back. You didn't want to make a mistake. So it's an 8-hour process. By using things like Microsoft HoloLens 2, the process was reduced to 45 minutes. So there's a massive increase in efficiencies, particularly in high-risk situations like outer space. There's also the NASA Orion project as well, part of the maintenance and part of the development of the Orion project. They found a 90% reduction in time of the processes as well. So it's really key. The middle one's quite interesting. So Black Friday, if anyone lives in the US, they'll know what Black Friday is. If anyone doesn't live in the US, they probably do know what it is now. But you get these random adverts coming out on Amazon and lots of other people talking about Black Friday. It's basically the Friday after Thanksgiving Day in the US. So they have lots of shop sales, but it's just expanded around the world as a concept now. But the thing about Black Friday is everyone goes a bit mad. So when the TV sets are reduced to 50% off, the doors are crowded, and the people trying to buy things are trying to get in the door. Now, for new staff, they'll never experience that in real, firsthand without actually being through a Black Friday. But Walmart have actually introduced some training to get them people, immersed in the situation, so they can train them how to react when angry customers are fighting over a TV set and that type of stuff. And this is being used today, so we don't, it's a kind of classic example. Looking on the right-hand side, you've heard Web 3.0 and social media 2.0, and the ability to do social media through, in a virtual world, in a metaverse, creating different content, digital fungible tokens. You can buy. The thing about digital artwork is it's very easy to copy, but you can allocate one owner to it by the DFT. So that's quite interesting. So you can start selling digital assets, which opens up a whole new marketplace. So obviously, if you think a DFT is worth something yourself, you might buy something, but it's one of those, the value of a DFT is in the value of those who want to own it, right? So it's a really interesting concept when you look at the metaverse. So if you want to link here a bit more back to the subject, so talking about 5G, Ericsson do many blogs, and there was a particular blog this is the avatars of our blogging team on the left-hand side, but on the right-hand side is just a link to one of the many blogs. And I'd highly recommend you following up some of these links. There's loads of material there, but it gives a very interesting insight. So, and these are very interesting characters as well. They publish lots of different things. So looking a bit more, how do you untether a device? Because everyone, today is typically using Wi-Fi, maybe mobile, but to get the processing power, you normally need a big battery or a big computer, right? So the middle scene is probably where we're at today. You have a big backpack, you're walking around with a VR headset on or an AR headset. There are some other augmented reality glasses. Microsoft HoloLens is a great example, which are self-contained. But as you get into 5G VR devices, you can get handsets that clip into goggle holders these days. You can do multi-user environments. And as we get to more the augmented reality glasses, obviously Google Glass was out there a little while ago. It was not quite augmented reality, but it was a good attempt at it. The HoloLens, I've already mentioned it, is a great experience. If you haven't tried it, I highly recommend going to one of the trade shows, picking up a HoloLens, putting it on. It gets across the concepts, and it's really great fun. So the big challenge, though, is that backpack in the middle. If you want the processing power or you want the battery life, because to power all these sensors, to make sure you've got the full 180-degree human vision, which when you look at the glasses, quite a lot of them have got quite narrow field of vision. So the wider the field of vision, the more realistic it is. The faster the refresh rate, the more realistic it is, the less dizzy you'll feel. So there's all kinds of processing implications there. So it gets quite challenging to meet that. So there's a whole lot of challenges, and we've got a whole panel talking about the challenges, and I've already mentioned a few of them, right? So having a lightweight device, ideally having a device that's a contact lens on your eye, but obviously there's not much room for a battery in there. There's not much room for processing, so the processing has to be done somewhere. Maybe using multi-access edge compute. Some people might know that as mobile edge, but Etsy have recently taken into the fact that different access technologies are included and rebranded that acronym. So there's a lot of looking at the edge compute, and we'll talk about that in a minute with some of the other slides. Standardized interfaces, so the standards are continually evolving. The 3GPP's done lots of activity, there's lots of other ITU activities, lots of other standards group working on this. You saw earlier the ADL API environment. APIs are going to be key. The ability to run services, to create an environment, to put things in the metaverse, to interface the metaverse externally. SDKs and APIs are going to drive it, and to be able to bind that business logic into there is really key. Just as bringing some reality from an engineering perspective into it. So if you want really high resolution, 4K or 8K, you need a sort of data rates looking on the right-hand side. So we've highlighted here kind of the sort of things that 5G is likely to be able to support and the sort of things that 6G is likely to be able to support. There's actually a GSMA white paper called Future Networks, which again, you'll get the link in the presentation. So I'd highly recommend reading that if you're interested. The other thing to think about is the application and what the demands are. So on the top left-hand side, this would be the AR glasses, being able to identify, so using AI to do image recognition, to be able to categorize, to send information through. So object identification has a high uplink throughput requirement and a low downlink throughput requirement. Conversely, if we look at the bottom here, this is using Microsoft HoloLens playing Minecraft. The Minecraft is superimposed on the room. It's got a low to high uplink throughput requirements depending on how you change the environment. So it's a very peaky type load. That means you don't have to have continuous availability, but there's a high resolution AR graphics with a high downlink throughput requirements. So looking at the typical tasks, so things like object tracking, object detection, map optimization, spatial mapping. So, being able to look at cloud data and point data, localize it, bring in sensors. So the ability to recognize things, so obviously video sensors, there's different types of other sensors, heat sensors, tactic sensors. So there's kind of all kinds of things. So you can look at whether processing is performed, whether it's performed on the XR device, the extended reality device itself, or where it's performed on the edge of the network. And you can see how what you would offload. So you might offload the map optimization and the point cloud data, or you might offload different types of things. And that's very much dependent. If you're doing a single application that you as an end user are using on your own, then having it all on the device is fine. However, if you're in an interactive environment, you're playing a multiplayer game, or you're interacting in a in a metaverse with a social media network, and you're actually physically interacting, maybe a lot more needs to be pushed onto the network itself. So again, there's another white paper reference there from Ericsson. So this is really a graphical representation of what I was talking about. So the bottom is a device processing. So this is your Oculus Rift or your that type of thing. The middle, where it's showing the mobile phone, that could equally be your Sony PlayStation, your Microsoft Xbox, or it could be a computer as well. The middle screen, the split compute processing, so that's where you have local rendering done on a compute device, which in this case is shown as a neck device, so a neck computer attached to glasses. And that link can be with a physical cable, or it can be wireless as well. But remote rendering and the really heavy lifting is actually still done by the network in that case. And then cloud processing, this is where most of the data is going backwards and forwards. So it's got a much higher demand on the network, but it's got a much lesser demand on the end device, which then reduces the processing power, the battery life required for the end device. So there's all kinds of interesting dynamics. I've already talked about the single user versus multi-user on the previous slide. This is an interesting slide showing different 5G as we go towards 6G. So everyone's probably familiar with the 5G. It started off as an enhanced mobile broadband, and then introducing the lower latency thing, so required for the metaverse, the URLLC, ultra reliable low latency communication. So that's the ability to support very low latency transactions, typically a few milliseconds, 5 or 10, 20 milliseconds type latency, but it's ultra reliable as well. So there's lots more signaling overhead to ensure that the actual bits get through. So you can't have ultra reliable and high bandwidth, for instance. There's a conflict between the signaling load and the user plane load in that case. And the other 5G service, most people know this as IoT, but in 3GPP speak, it's known as machine type communication. And the M stands for massive machine type communication. So that's just simply representing that with 5G, the number of devices can massively increase. And the reason that becomes a challenge is because in a mobile network, you've got the data or the user plane and the signaling or the control plane. Now, with IoT devices, the problem is there's very little data that goes backwards and forwards, unless, of course, it's a video device. But normally it's quite low volume. But when you've got a massive number of devices, it overloads the signaling channels. So therefore, there's a whole tranche of 5G, which was dedicated to doing very optimized signaling and dedicating more of the resource blocks to carry signaling traffic. Now, as you go over to the right-hand side, the 6G standards are still in their infancy, but they decided to expand the triangle into a hexagon, which is very apt if you know anything about radio planning, because they always plan with hexagons, right? But thinking about immersive communication, the metaverse will be completely immersive and merged reality and that type of stuff. We require global broadband, omnipresent IoT, so it's always present, always communicating. But so a great example of that is a digital twin. So you might have a digital twin of a network, for example, that things can be tested on first before they're implemented in the real world, or a digital twin of an AI model doing something as well. So, or the AI model, the digital twin probably is an AI model. So, finally, there's a number of other dimensions in the 6G side of things. But how do we enable 6G? So 6G will enable lots of different sense services. So the Internet of Senses as opposed to the Internet of Things. This is massive multi-sensory merged reality. This will be a true enabler of the metaverse. So I'm not saying we can't do the metaverse today on 5G. What I'm saying is it's going to get even better when 6G comes along. So connected intelligent machines as well. Again, today we have a connected factory. We have high-speed communication between machines in a factory environment. But with the 6G, new services will come along. Interactive 4D maps, precision healthcare, but personal concierge services. They're just examples of kind of what could come. So and finally, it's very important to all of us. We all know about global warming, particularly in countries like Bangladesh and in areas served by XIATA. So there's regular flooding, and the flooding is getting worse in various different countries around the world. So sustainability is really key. So energy management, being able to optimize, for example, if you imagine Bitcoin, that was consuming huge amount, equivalent to countries worth of energy, just simply to keep the blockchain alive. Ethereum did something quite interesting recently. They're more decentralized. They moved from a completely decentralized environment and flipped it over to a more centralized environment. That dramatically reduced the energy required for Ethereum versus something like Bitcoin. Now that's interesting as well, because one of the operating systems, and I call it an operating system, touted for the metaverse is the Ethereum landscape itself, which gets quite interesting. And to get access to that, you need very good mobile coverage. But at the same time, it's very important to consider things like the energy consumption. So the vision for the future is that a cyber physical continuum. So this is where you see the Internet of Senses, the connected world, and being able to observe and track things in real time. So, wearable devices, embedded devices, providing that network connectivity is going to make it a very interesting world in future. So when you combine that with being able to go into the virtual world as well, that means it's going to be extended quite interestingly. We have another white paper. I'll keep giving links here, so there's lots of reading to do as homework after this presentation. But this link is covering the connecting a cyber physical world. So it was written in quite recently. So it was first published in November 2020, but it presents a 6G vision for 2030 basically at the moment. So finally got onto the subject, AI. So it's a good job, got an extra few minutes here. We've got 10 minutes left in the presentation. So what I'm showing here is basically the evolution over time as things have rolled out. We've moved from having manual processes to more automated processes, incident-driven operations, to start doing things proactively and to use data-driven AI and cognitive networks to run network operations. The enablers are AI itself, the fact it can be automated, and also the fact that it's cloud, so things can be scaled up and scaled down. Now, once the 5G core is in place, network slicing can dramatically increase the control over individual quality of experience, which is really important for the metaverse because you've got to guarantee the low latencies for specific services. And we've talked about the differences required. So some services will be really high performance. Well, just have a look at network slicing. So for example, mobile broadband, it's got to be reasonably available. 99% availability is relatively low in the scale of things I'd expect, but yeah, no, so 90%, 9% available. It's got to be there most of the time. Most people, will do a best effort type service, and there's no real SLA. So if it doesn't work, you don't get a feedback or anything. When it comes to remote surgery has been touted for 5G probably since 2015, but let's use it as an example here. With remote surgery, if there's a delay in the transmission from the surgeon performing the surgery in, let's say, in London, and the remote surgeon maybe in one of the sub-Saharan Africa countries, if there's a delay, then that could mean that scalpel carries on cutting where it should not cut. It could do something quite serious. So it's important that the top priority is given, the latency is managed, the throughput is fast enough, and of course it's secure, so no one can hack into it as well. Smart factories is another use case. So slightly lower priority than the remote surgery, but still very important. And the security is still reasonably important. There's an SLA on throughput and latency. So let's say you have image processing is a very high bandwidth, and it needs to be passed up to a cloud server to get it to do image recognition, to detect faulty goods. Those type of SLAs are important to monitor. So it's important to have some sort of intent-based management, which is using a knowledge base of known issues and known relations, and to be able to drive the AI based on intent as well. So you set a business intent, such as for the remote surgery, we will deliver all messages within 2 milliseconds with latency, with the throughput of, and it doesn't necessarily have to be a high throughput, but it's the intent to provide that. And that can be fed into the system, and the system will use that to control. So it will use machine reasoning to handle any conflicts, to draw conclusions to the data. So for example, in the case of we're doing a Metaverse to identify, let's use the toilet example. You might not want to go to that toilet because it's busy and there's all kinds of different rules. Well, it won't be rules, it'll be machine reasoning in that case. And there's various agents, so to control actuators, to control models, to have statistical analysis, so probabilistic methods for looking at things as well and coming to conclusions. So doing things like root cause analysis based on historical activity. So this is an interesting slide. It's also, again, showing the journey from reactive, incident-driven management to proactive, data-driven management. And as the value goes up as well. So more technology is used. So this basically shows 6 different lines here. So the initial deployments of AI have all been about improving efficiency. So looking at power saving. So the cost of energy around the world has gone up massively in the last 12 months. So, if you can save 20%, 15, 20, 25% of the energy by having an AI solution manage that, then that's really important. If you can improve the efficiency of your workforce, so, reduce the site visits, the truck rolls, all that type of stuff, or even within an organization to improve the efficiency of utilization, then people can do the more interesting tasks. Now, the interesting thing about, let's take an example like power saving. You do save power, you save money, but it has an impact on the performance. So there's a trade-off there. So if you go to the next level down, then you want to be able to use the AI to manage the customer experience. And there are cases, particularly in something like mobile, where the amount of power you use equates to the amount of interference overall. It makes the overall signal worse for everyone, that you can reduce power and you can improve customer experience at the same time and do a win-win. And it's only by using AI models with machine learning, reinforcement learning, machine reasoning, that you can get to this level of things. Sustainability, again, that's the power saving case. Revenue generation is quite interesting. Everyone's looking for new revenue sources. So the Metaverse is a great example where it has a tremendous possibility to generate new revenue for many organizations. That's why Facebook have placed a massive bet on it. That's why this conference even is featuring it as a major topic. And then we've talked about measurement of trust with that Catalyst project that ADL XAR Dialogue Sri Lanka did, and they actually won a sustainability award for that trust measurement of trusted AI from the TM Forum in the first phase, which was really good. But with AI, it's important to use AI to measure the trust as well as trusting the AI. So it's 2 different dimensions. So, and as Suganya said earlier, the Metaverse even presents greater challenges. So that's a very important piece of work that we were looking at earlier on. So looking at an innovation platform, this is kind of showing the different layers of a mobile network, transport, cloud infrastructure, the access, the mobility. So as you travel around with devices, as you travel around VR headsets, roam around the world, how it's managed, orchestrated, and how it can be applied. You can make AI do things like for the infrastructure, do the power optimization, the link adaptation, MIMO, massive MIMO, the number of antenna beams. It's very complex to steer the beams and make sure they're pointing at the right devices. So definitely requires AI to perform massive MIMO optimization. Moving up the stack, the access and mobility, handover decisions, dual connectivity control. So maybe it's still using a 4G core with a 5G user plane. So being able to control all that. And spectrum load balancing. So there's only a finite amount of spectrum, and the really valuable low frequency spectrum that can penetrate buildings, you want to use only in those cases where people are indoors. And then the algorithms required to distribute the load, the user plane and the control plane across the different spectrum is quite key. And finally, the orchestration is really key, and monetization, of course, drives all of our businesses today. Here's some examples of AI being leveraged in the metaverse. So it's actually from a different video than the one I showed in the beginning of the deck, but there's all kinds of examples of a human-machine coexistence, distributed intelligence around the different parts of the network. So if we take the example where she was walking through the woods in the beginning, she was looking at different stats, different information was coming up, the weather came up, she was going fishing, that was quite interesting. The whole artificial sort of creation, so virtual presence, so she was sitting next to her daughter while she was fishing, and also that type of thing. So there's lots of very interesting things where AI can be applied to update and augment the information available. Finally, AI in telecoms. So just getting towards the end now, we've got about a minute left. These are the sort of area, the technology where AI can be applied to control. So with reinforcement learning, you can distribute intelligence, so use federated learning around. Our whole department is known as cognitive networks, but the whole ability for the networks to run themselves, effectively optimize themselves, grow themselves, and improve through automation. Got to trust it, and obviously have an AI infrastructure that drives it all. And basically, the idea is to improve efficiency through automation, power our products, and also enable new services such as the metaverse, IoT, and telecoms. And just looking towards 2020, 2030, sorry, wrong decade, the Internet of Senses, connected intelligent machines, a connected sustainability world. And to do that, you need limitless connectivity, trustworthy systems, a cognitive network, and network compute fabric. And that's it for me. So I'm sure there's some questions.
We are back to our Q&A with Steve Bowker. So Steve, we've got a couple of questions for you. So to start off, will satellite communications one day replace current networks and power the metaverse soon? So this is in relation to something like Starlink. What are your thoughts?
Okay, that's a very interesting question. So satellite will form a part of the communication network infrastructure, obviously. One of the challenges with something like the metaverse is the whole capacity versus coverage issue, right? So the satellite's great because it's got a good coverage from flying over. However, you always get interference in a mobile network. And if I just take a step backwards, let's talk about whether Wi-Fi or 5G is more suitable for metaverse. Now, Wi-Fi is great if you're a single user, but what's happened in the mobile standards is they've been optimized over the years to handle multi-user, to handle all the interference, to handle all the capacity type things, right? And the ability to scale that by putting extra cells in. If you put that in a satellite network, you'll end up having so many satellites flying around in low Earth orbit, there's a big danger of them crashing into each other, right? So, and one of the challenges about satellite communication and satellites is if a satellite crashes into another one, then there's a lot of debris flies around and it takes out a few more satellites, and you get to a situation where all the satellites get destroyed in one big sort of cataclysmic event, right? So eventually, ultimately, there is a certain amount of capacity up in space, even with all that space up there, in all the different orbits and stuff. So, in a mobile network, it'll be a tiered structure. You'll always have a terrestrial network on the ground, and it will go as small as really small picocells, which might be, millimeter wave or higher terahertz wave in 6G, all the way up. So, to answer the question, no, satellite won't replace the mobile networks of today, but it will supplement it and augment it. And if you're rich enough to just have a satellite subscription, then go ahead, go for it. But you might find it's variable, and as more users use it, the capacity goes down.
So just moving on to Q2. Metaverse will not need mobility as much. So can't we make things much simpler and efficient without worrying about mobility? So what's your thoughts on that?
Yeah, so there are certainly use cases where if you're sitting in your room and you're just going on a trip around the world, you can just use your local network at home and use virtual reality. The real power of things is when you start looking at mixed reality and augmented reality. That's where the real mobile story comes in. However, even on that capacity aspect I talked about, to get the bandwidths that you require at low latency, you will get a better quality of experience on mobile. Now, going back to that cost thing, it will probably cost you more money on mobile. So there has to be a reason to do that and value for doing it. So yes, most of the VR, in fact, the VR today is mostly on Wi-Fi in your lounge. So.
Okay. Thanks, Steve. And the final question is, are 5G capable devices able to support the data streaming requirements for real-time rendering of virtual environments in the metaverse?
That's an interesting question. So it depends on the resolution and the optical size and that type of thing. So there's been loads of calculations done, and some of them definitely will do. It's more capacity. The devices will handle it. You might need a big compute to do it, so they might need to be very powerful in terms of compute capability, which is why we talked about having a backpack rather than having a device on your head. So the other side of it is, we talked about the splitting the load. So some of the load would be done by the network on the mobile edge or the multi-access edge compute. So using edge compute and a device definitely is the answer to that question.